Hello, everyone, and welcome to the final session of the computing track of Sbgames 2021. This session is about virtual humans, and we are going to have here four very interesting papers that will handle different aspects of virtual human in computers. And every author will have 10 minutes for their presentations, which will be followed by a few questions from the audience. So if you have any questions during the presentation, you can use the comment section on YouTube to ask your questions. You can also use Discord. If you have any questions, you can ask it there. I will be checking both places. And then after the presentation, I'm going to be asking the questions to the authors. Just remember that there is a small delay in the YouTube transmission, so make sure you ask your questions before the presentation ends, so we have time to ask the authors. And the first paper to be presented here is called Perception of Personality Traits in Crowds of Virtual Humans, and it's going to be presented by Lucas Nardino.
Hello, everyone. Okay. So, hello, everyone. My name is Lucas. I am undergrad student in computer science at PUC-RS. And today I'm going to present you our research on the perception of personality traits in crowds of virtual humans. Firstly, I would like to give an introduction on why we simulate crowds. There are two main reasons. The first one is entertainment purposes. So series, films, games, any kind of media that requires a large amount of people, it's easier to simulate rather than to use a real crowd. An example, on the left, we have an image from the movie Ben Hur from 1979, in which we have 50,000 people sitting on the benches of the stadium. And for the time the movie was made, that number was really groundbreaking, really impressive. But with the technology we have today, we're able to simulate much larger amounts of people. In example, the image on the right, we have a frame from one of the Lord of the Rings movie, in which we have a whole army of simulated agents. And the second reason to simulate crowds is safety. So engineers and architects use crowd simulators to see how a crowd would react in a panic or stressful situation, like fires, an example, and see if they need to insert another exit door or fire extinguisher or um, any kind of safety protocol that will ensure the well-being of the crowd. Some related work. So the main core of our project is BioCrowds, which is a model for crowd simulations that is based on a space colonization algorithm that was designed to generate live nation patterns. And in this model, a discrete space is populated by a set of marker points in which the virtual agents will compete based on a proximity criteria and capture range. So effectively, they compete for the space in which they occupy and move. BioCrowd's model is a goal-oriented crowd simulation. So each agent has a few parameters, such as his perception field, which is a circular threshold in which all the available markers will compose the n available marker set, and some general parameters such as his position, goals, and desired maximum speed. As in math, the motion vector will consider the agent's position and all of its markers, and also the markers weight formula, which defines the weight of each marker that is defined by the goal direction, and the and uses the f function that prioritizes the closest marker in order to maintain the minimal effort property. Image A illustrates 5 agents that are competing for space, and we can see that even though the agent in the center is very compressed by the other 4 agents, he still has his own markers and doesn't invade the other agent's space. And the image B illustrates various agents in which every green line represents one marker captured by an agent. There's also the BioCrowd's normal life model, which is an extension of BioCrowd's that achieves the main characteristics of Helbing's normal life, such as the minimal effort to reach a destination, an individual desired speed that corresponds to the most comfortable walking speed, and the personal space. The BioCrowd's normal life aims to improve the realism of the agent's behaviors in evacuations or panic situations using the comfort bias, which is presented as a function of the available area for each agent as shown in equation 4. When computed in the modified markers weight formula, the comfort bias will change the personal space of each agent dynamically. Hence, the agents will capture the marker in which they feel more comfortable staying in. And in order to include personality traits in our agents, we chose the Ocean psychological traits model proposed by Goldberg, once it is the most accepted model to define the personality of a person. The Ocean stands for openness, which is openness to experience, conscientiousness, that will reflect the space conscience, extroversion, that will define the sociability and talkativeness of a person, agreeableness, which is the tendency to be cooperative, and neuroticism, that defines the emotional stability of a person. The extroversion trait is highlighted because it is the trait we use in our model. So our proposed model, we propose a model that parameterizes the crowds based on the extroversion trait that would reflect, as said before, the sociability and talkativeness of the agent, as well as how comfortable the individual is around crowds and other groups. So in our model, each agent has his own emotion profile that will reflect his ocean traits, as shown in figures 1 and 2. And the extroversion trait will be computed in a modified normal life markers weight formula, as shown in equation 6. So basically, what our model does is activate dynamically the normal life model based on the extroversion trait of the agent. Here we have a comparison between the three models. So we have the agent's goal highlighted in yellow. And on the left, we have our proposed extended model of biocrowds using two different levels of extroversion, 0.8 and 1. And you can see that the agents will have a different distance from each other depending on their extroversion level. In the center, we can see an implementation of the normal life model. And you can see that the agents will take a distance from each other depending on the comfort bias. So they are more distant in general. And on the right, we have the original biocrowds, which the agents only capture the marker that is closer to them. So they tend to cluster together around the globe. Here we have a simulation evolution with 50 agents using our proposed extroversion model, again, varying from 0.8 to 1. And you can see that in the final simulation frame, the image C, that the agents highlighted in blue have a higher extroversion trait. So they occupy less space and tend to cluster together. And the agents highlighted in green have a lower extroversion trait. So they occupy more space and keep a greater distance from each other. Our research methods. So we wanted to see if people perceive the interactions or the emotions in the virtual agents. So we ran a Google Forms survey in which the users interacted with the simulations using 3 different scenarios of interaction. So in scenario 1, the users only observed the environment and they used a special camera that didn't affect nor the agents or the environment. In scenario 2, the agents and the avatar are based on the original BioClouds model, and now the user can interact with the agents as well as occupy more space while walking. And in scenario 3, the avatar and the agents are based on the BioClouds normal life model. And after interacting with the simulation, the users answer 2 different questions that would reflect their perception on the personality traits and interactions of the agents. So the first question was if he noticed interactions between the agents, and the second one, if he perceived different emotions or personalities in the agents. So some experimental results. The perception of the personality traits of the virtual agents and the interaction between them will depend on the user's form of interaction. So the results are user interaction dependent. And in scenario 1, where the user is an outside observer, few users perceived interactions. But in scenarios 2 and 3, where the users incorporated respectively the biocrowds and the normal life model, the users perceived agents interacting among themselves, as shown in figure 3, but they have difficulties identifying emotions and personalities, as shown in figure 4. Some final considerations in future work. So the data we collected indicated that the kind of interaction the user has is a key factor in the perception of the personality traits and the interaction of the agents, and that the users tended to only perceive the interactions and the extroversion trait in the scenarios where they actively interacted with the agents. As in future work, we pretend to expand the influence of the ocean factor, modeling all the 5 factors to have a full emotion profile for each agent. Also to add facial expressions for the agents, which we already have. We are just currently working on linking the facial expressions with the ocean profile, and also to implement more than one physical appearance for the agents, so we have a more realistic simulation. I would like to thank the CNPq, CAPES, and PUC for funding this work, and to the shareholder for the attention. Here are the references, and thank you.
Okay, thank you. Thank you, Lucas, for the great presentation. Let's see if we have some questions. And yes, we have one question from Bruno Feijó. He is asking, how about to add sound to the agents, for the agents to complement the geometric factors?
Yes, adding sound would be a great way to improve the realism to the simulation, as well as said in the future work. I think that would work well with the different appearance for the agents. I think that would be a good idea to improve the realism of the simulation.
Yeah, every time you add one extra feature to the system, including all you facial expressions, more details to the animations, you go beyond and you improve the way people will perceive the emotions.
Yes, as said in the presentation, the kind of interaction the user has with the simulation will improve his perception on the personality or interaction with agents. And in crowd simulation, the more realistic the simulation is, the better you will perceive this. So
Yeah. I have a question. Did you think about using the ocean model from real people, like going applying a Big Five questionnaire to extract the ocean from real people, and then apply that to the virtual humans to see how the behavior of those virtual humans, if they will reflect the behavior that the real people that provide it would have?
yeah, we didn't think of that, but that would be a good idea to actually see if the model would reflect as realistically as possible the ocean profile of a real person.
Yeah, I think especially if you're trying to simulate the behavior of real humans there, maybe just by having their personality there represented by the ocean model, you could have a real simulation of their behavior in the simulation.
Yes.
That can be a very interesting work. Okay, let me see if we have more questions. Um, Okay, we have a question from Joaquim Bento. He's asking, why in your tests you vary from 0.8 to 1 only?
We use 0.8 to 1 because during the test prior to the Google survey, we found that was the extroversion that better work with the agents. So in the model itself, the agents show the distance, the varying distance from each other well in the 0.8 and 1. So that's why we use it.
Okay. Okay. Soraya is also saying here that they have, so you probably your group, you have another work where you're already applying the ocean model from real people in video
From the real
sequences.
video
So
sequences. Yeah.
yeah, so that's really good. I think your work has many potentials for different ways of evaluating how people would behave in their simulation based on the ocean model. I think that's a very interesting work you have there. Okay, well, there are a lot of people here congratulating you, but I don't think we have more questions. So I think we can move to the next presentation. Thank you again, Lucas, and congratulations for a very interesting work. Okay, so the next presentation is going to be biotraffic, a bio-inspired behavioral model to vehicle traffic simulation, and Carlos is going to present the paper to us.
Okay. Hello, everyone. My name is Carlos Quadros, and I will present the work Biotraffic, a bio-inspired behavioral model to vehicle traffic simulation. And they are so authors of this work is Gianna Damati and Alessandro Bicho. Oh no. Next.
Maybe try to click in the slide. Maybe you didn't select the window.
We'll translate for next page. No.
No? Yeah, maybe we should change the order. Maybe you can exit the transmission and then we check what is happening and then you return after the other presentation. Is that okay?
Okay.
Okay, all right. So let's move to the next paper. Scripted behavior of virtual humans for anthropological hypothesis testing, which will be presented by Gildo.
Hi everyone. Uh, Hi everyone. My name is Guido, and I'm an undergrad student in computer science at PUC-RS, and that's the paper about an authoring tool to provide groups and crowds animation using natural language scripts. This presentation has 5 main slices: the introduction, the related works, the method, the results, and the final consideration. So let's start. Introduction. One way anthropologists study the past is by attempting to reimagine the culture, customs, and rituals of ancient civilizations. Thanks to freely available game engines such as Unreal Engine, we now have tools that allow us to simulate places and populations. However, people without animation programming and game expertise must first learn how to use these tools in order to alter simulation themselves. In this work, we abstract the world building features in Unreal Engine so that people without animation programming skills can focus on creating scenarios. Using the system, authors can define the roles and behaviors of different people, small groups, and crowds. The related works. The first work proposed a script system that allowed users to describe the behavior of groups and individual agents. The second one describes a model to create complex behavior capable of generating plans of agents' goals. The third one proposed an interactive multi-agent system to improve the reusability of agents. And the last one, the objective is to build parameterized simulation, especially and temporally located in large-scale public environments, especially in historical contexts. The method. That section also has 5 parts: the presentation, the program flow, the scripts, the initialization, and the execution loop. First of all, this work uses two technologies to help the simulations and the agent's movimentation. The first one is the Unreal Engine, and the second one is the BioCrowds. The Unreal Engine was chosen because three main reasons. The first one is the nav mesh, which help us control agents and creating the path between the agents and the goal. The second one is the begin play that help us to start some values before the simulation starts. The third one is the tick, which allow us to control the agent making the animation illusion. The BioCrowd is a crowd simulation model created by VH Lab. It's allow us to avoid the agent's collisions and simulate the crowd's behaviors. So the nav mesh, besides BioCrowds, will make the agents avoid all possible collisions over the simulation. The model. In that picture, we can see the main fragments in the code. The first one is represented by green color, and it's the scripts that the user wrote to run the simulation. After that, besides the Unreal begin play moment, the code load all scripts on memory and create the agents on starter points. So the tick loop starts and the prototype run the scripts making the agents follow all commands. The scripts are split in two different types. The first one is the main scripts that control all simulations events. The other one is the behavior one, which control a behavior of a designed agent. The main script has four types of commands to control the events. The first one is the create, the second one is the when, the third one is the profile ID, and the last one is the all profile. In the create command, we can define a number of agents, the profile, the model, and the place. The profile is a way to make agents follow similar behavior and trigger some events. The when command will trigger some other command when an agent of a specific profile arrives in some place. The profile ID command enable us to make one specified agent follow some behavior in second t of time, of execution time. And the all profile command is really similar to the profile ID command, but it's make all agents of determined profile follow the command. The behavior scripts has two type of commands, the goto and the play. And that script type allow us to describe behavior as go to kitchen and start to cook. The go-to command defines a goal to the agent and can be used with random location or use some flags to narrow that random locations. The last command is the play one that makes the agent play some animation as dancing, sitting, or something else. That animation must be inserted in the Unreal project before the scripts use it. And there's the results. This section has four steps. In the first one, we describe how to prepare a scenario two agents can be controlled. The second one is a simple example in a small residence. The third one is a more complex example in a mall. And the last part, we describe the evaluation method to test the prototype. So the mapping in the residency example, we model an real scenario based on that blueprint. To control the agents, we add invisible box on scenario and give them name and flags. After that, we wrote the scripts that will be used in that scenario. And there is a video of the scripts running. So that script describes three agents' behaviors. Two of them, the pink dancer ones, goes to the room and start to dance, and the other ones stay in the bathroom. For the mall example, we made this scenario based on the left blueprint and also mapped it with invisible region box. That's the scripts we wrote to run in the mall example. And there is the video of the scripts running. So in the mall simulation, we created more agents of different profiles that walk between the halls and the stores. And after 30 seconds of simulation, the alarm starts and all agents leave the mall by the emergency exits. Validating. After create the prototype and the scenarios, we validate it with two users. The first one is a specialist in computer animation and simulation, and the other one is a psychology student with no technical skills on real or simulation. During the test section, user was asked to learn the scripts command and thus to try to fulfill a list of tasks in the mall model using the prototype. According to the specialist, the prototype can speed up the process of the final simple agent's behaviors in a practical and fast way, as well as speeding up the process of changing information to carry out new tests in same scenario. After set up the scenario and add all animations and models, the authors introduced the Unreal to the novice user, basically explaining how to start and pause the animation. And after some explanation of how work the scripts, the student was able to reproduce a simulation with sad and happy agents following different behaviors. The final considerations. A prototype were developed using Unreal Engine in order to validate the model. The prototype was tested by users, one expert on animation and one psychology student without any programming or animation skills, with different fields who found the prototype easy to create agents and groups with different purposes. future works, this research aims to distinguishing and important paths for the future work, the technical development side and the application side. On the technical development side, we intend to go deeper on new commands and validations, making the scripts easier to use. And on the application side, we can mention one example of integrating with Peshakamak Desert model, so that script can be used by researchers to define hypotheses and generating visual behaviors. That's the reference, and that's it. Thank you for your time.
Okay, thank you, Guido. That's a very interesting work as well. We already have one question here from Paulo. He is asking if the prototype is available anywhere.
Yes, we have the GitHub repository with the prototype, and it's specifying the paper. In the file and paper, you can see the link with the prototype.
Yeah, if anyone is interested in seeing the code, can just access the paper and the link is available there. That's great. While people are sending questions, I also have a question more related to Unreal Engine, like how difficult it was to implement the model in Unreal. Like probably the previous
Yeah.
version was using Unity, I guess.
No, it was a project in
Yeah.
VH Lab with scientific research I entered, but uh, there need to be used Unreal with the main initial idea was integrating with the Peshakamak Desert model. So that model was made in Unreal. So in the beginning it was to the Unreal Engine. And it's really difficult. I didn't have any experience with any engine. So the first part I was really hard to understand and using the features. And the first version I can see the prototype, first prototype version was a mess of code that I wrote with the Unreal's functions, and yes, it was really complicated.
Yeah, Unreal by nature, it's very complex. There's a mix between Blueprint and C++, and you have to combine both in a very good way in order to make everything work there.
Yeah.
Okay, we also have a question from Alessandro. He's congratulating you, and then he's saying that so BioCrowd model is local planning. How do agents calculate path planning using a real engine from scripts between rooms?
So the nav mesh help us to calculating the path planning. So we give the agent point and the final point, and the nav mesh know our object that is in the scenario. So the agent can go to the start to finish, and the biocrowds give us the agents to avoid each other, so they we don't need to worry about this in, in the scripts.
Yeah, so you have the normal path planning, the path finding from Unreal to calculate the
Yeah,
path, and then the BioCrowd gives you the changes that you need to apply to avoid the agent, or to avoid collisions between agents.
yeah, that is.
You're kind of combining both models in order to make it work correctly. Okay, let's see if we have more questions. Let me check Discord. No one is asking anything on Discord. Okay, so congratulations, Guido. Another very interesting work from the group of Soraya. You guys work a lot with human behavior, simulation of crowds. That's really good. Oh, we have one more question. One more question just to finish. Do you know which model is used? A star is actually Alessandro is complementing his question from before.
Okay, on Knife Mesh, no, I don't.
You probably are using that mesh from Unreal, right?
Yeah,
Okay, so I can answer for you. For you, it's A star.
thanks.
Unreal by default. If you just use the normal path finding there, it's A star for the movement. Okay, so I think we can move to the next presentation, which will be Okay, Carlo's back. Let's see if now everything is going to work fine. So the next presentation is going to be biotraffic, a bio-inspired behavior model to vehicle traffic simulation.
Okay, now?
Okay, yeah, it's working. You can present. We can see it.
Hello, everyone. My name is Carlos, and I will present the work Biotraffic, a bio-inspired behavioral model to vehicle traffic simulator. There are also authors of this work, Gianna Damati and Alessandro Bicho. This work is organized as follows: introduction, related works, biocrowds model, biotraffic model, results and analysis, conclusions. Introduction. The proposition of traffic simulation models requires considerable effort. There are several techniques for modeling traffic behavior. However, existing approaches are often focused on a massive mathematical description of traffic flows. Existing traffic modeling methods require careful parameter tuning, obtaining visually convincing results. Proposed models are limited to reproducing previously programmed behaviors. This research proposes a novel traffic simulation model in virtual environments called biotraffic. The main idea of this model is a bio-inspired agent-based method that occupies the simulation of space based on available markers on the environment. The proposed model is not a new car falling, but a different, innovative way to simulate the behaviors of vehicles displacement in simulated environments. The proposal is based on BioCrowd's model by Bicho et al., which proposes behavior model for crowd simulation. Vehicle traffic simulation models are characterized by their approaches. There are three approaches to analyzing traffic simulation. Microscopic models focus on agent detail. Car falling model is one of the most used for the computation representation for vehicle traffic. Macroscopic models focus on the environment in general. Mesoscopic models are hybrid models, working with micro and macro models. And table 1, we have a summary with the main contributions related works. And now I present BioCrowd's model. The model was originally proposed by Hunos et al. To the model development veins of plant leaves and tree branches by disciplining plant harmony called auxin. Each time the agent E moves to the simulation, it's necessary to update its position P, T, and consequently to target vector G, T. The S contains all the N markers closest to agent I and the simulation scenario. These markers are part of the precipitation area, where S and A1, A2, AN. The field run, calculation agent, movement, and the orientation considering the markers in the precipitation area. And now I present biotraffic model. In crowd simulation, each entity, in order to arrive at the desired location, contests spacing using markers as a resource available in the environment. The distance between markers play a key role in two important aspects of the simulation: computation cost and realism in the agent's movement. In order to represent the movement carried out by vehicles and their respective restrictions. The biotraffic proposal is based on model widely used in autonomous vehicles, the Ackermann steering geometry model. In the figure 2, we have a Ackermann steering geometry model. The ICR, instantaneous center of rotations, aims to provide an external reference point of orientation, and later collaborate with the direction calculation with the other points of the vehicle. We adopted a biotraffic model with a perception angle of the markers correspond to 2 SWA and would reproduce the same direction effect in the vehicle, Richard area. In the figure 3, perception angle agents of markers corresponding to 2 SWA. Biotraffic model. The markers not only inform a spatial reference scenario, an approach that integrates the concept of theory reasoning to biocrowds model as proposed. The markers inform through on their attributes by variable called surface capability, the current maximum traffic lane speed. The markers inform the displacement available of agents and the spatial coordinates are used to calculate some vector in the direction vectors obtained from each marker containing the personal space of the vehicle. The movement of each agent is calculated interactively. The position pt and the target vector gt are calculated at each simulation step. Results and analysis. For your development, we choose the next logo to model of traffic simulations, the validation of the development model as performance comparing IMSAN. Traffic simulation results a commercial simulator. And in the figure 4, we have an interface biotraffic simulator in the net logo. Results and analysis. In the figure 6, we have a vehicle's input flow per lane and the comparison in biotraffic and IMSAN. Vehicles in the figure 7, vehicles descent in lane. In figure 8, vehicles travel time during simulation. And figure 9, vehicles average velocity in line. Results and analysis. We measure behaviors in terms of simulation, realistic traffic lane change, and merge behaviors are important features in multi-lane simulations. When a vehicle changes lanes for one lane another, this can have the effect of a wave loading both lanes. The merge of two lanes may reproduce a reduction capability to do the generate bottleneck. The behavior is reproduced by proposed model, just that damaged vehicles remain with their markers. And figure 11, in figure 10, I have a snapshots of changing. And figure 11, we have a snapshot lane merging. Conclusions. From analyzing the data obtained from the model simulation IMSAN simulator, it was verified that proposed model present results correspond to those of the vehicle traffic simulator. Regarding visual results, the methods reproduce characteristic behaviors in multi-lane traffic, lane change, and merging behaviors. Biotraffic is different from the more conventional model widely used because it was the capability for the new types of simulation, the interaction of agent made with the environment. It's not with the older agents. In future works, we will improve the theory reasoning and the service capabilities would have differentiates markers to propose improvements to the model by adding georeference data from open maps and implement parallel processing techniques on GPS. And we have now difference for the presentations. Thanks. Questions?
Okay, thank you, Carlos, for the presentation. Now let's see if we have some questions. I don't see anything yet, so I have a quick question here to you. For what I understood here from the presentation, you adapt the model of biocrowds to simulate vehicles. Is that right?
Yes.
Okay, so how
Yes.
difficult it was? Like the model was easily adaptable, or did you have to implement a lot of changes in order to have it simulating vehicles instead of people?
The principal problems in adopting the model by crowds are angle of the target, because the vehicles we have more the less degree of freedom of the humans, for example, right? And the vehicles we have restriction of direction.
Yeah, the kind of movement they can perform, it's completely different. Like humans
Yes.
don't have restrictions, cars they have. Like
Yes.
they must turn, there is a limit in physics. There's a whole physics simulation for the car movement.
Yes.
Okay.
And we use it, the Ackerman for the model for represent the vehicle in the model.
Yeah, yeah. Okay, thank you. There are some questions here from Paulo. Sorry, both they are asking a similar question. I'm going to read the question of Paulo. Basically, he's asking how. Wait, it moved. How is the performance of the model? Would it be viable to simulate, for example, an entire city in the model?
I don't understand the question.
Like about the performance, how expensive it is to run the simulation, your simulation simulating
The
vehicles,
cost, the
and
computational cost.
yeah, the computational cost. And he's also asking if it would be possible to run the simulation of an entire city at the same
The,
time.
the computation cost is it's the same of the bicrowds model, because the markers and the agents in the scenario is it's the same cost computation, and um, uh, if you have a parallel process, we have it's the better.
Yeah, if we are able to put the model to run on GPU using parallel processing, we might be able to simulate an entire city there. Is that right?
Yes.
Okay. All right, perfect. So Natalia is also asking, does your model allow for a difference in lanes, like fast and slow lanes or street signs?
Um, in the in the test, we have the same velocity for the all the vehicles. Um, all vehicles. Mhm, yes. Be sure answer for the complexity of biochromes, and no have difference in the lane, because the markers, all markers have the same velocity in the scenario.
Okay, okay. What are your next plan for future works? You want to implement the parallel version, or what is your priority for next future works?
um, Reproduce more results and parallel GPUs, and um, um, we have um, others other problems.
Yeah. Okay, all right. Thank you, Carlos. You have a very interesting work here. So let's move to the next and final presentation, which is also from the group of Soraya, Perception of Charisma, Comfort, Micro and Macro Expressions in Computer Graphics Characters, and the paper is going to be presented by Victor.
Hi everyone, my name is Victor and I'm a PhD student at PUCRS and I will present the paper entitled Perception of Charisma, Comfort, Micro and Macro Expressions in Computer Graphics Characters. Face can be considered a center of human communication. It's stronger than that we perceive emotions. Paul Ekman defined microexpressions to be expressions on the face that change drastically in 3 to 5 frames. Micro and macro facial expressions can be used to provide more realistic characters in many applications such as games and simulations. In the work of Queiroz et al., the authors investigate whether people could perceive facial micro and macro expressions in a similar way with CG characters than with real people. Avoiding the feelings of discomfort is important for a CG character's face to be more human, improving the experience of watching movies, playing games, and more. Another aspect that can influence the human perception of character is charisma. According to the dictionary and to Ada, charisma is a type of leadership that a person, in our case, a character, can exercise over one or more people. So our goals are to investigate whether the perceptual analysis of CG characters in 2014 is similar to people's perception in 2021, and to investigate whether perceived comfort and charisma influence the perception of micro and macro expressions. With this, we formulated 3 hypotheses. The perception of micro and macro facial expressions of CG characters in 2014 is similar to 2021. The perception of micro and macro expressions in positive emotions is similar to the perception of micro and macro expressions in negative emotions. Subjects consider that our evaluated character is charismatic and comfortable according to their perception. For this, we reproduced partially the work of Queiroz et al. We used a more recent CG character, a cartoon character, collected perceptions regarding the character's micro and macro expression through a questionnaire, and we investigated the perception of charisma and comfort in relation to the character in the image above our character and the image below the character from Queiroz et al. In the work of Haggard and Isaacs, the authors first reported microfacial expressions in nonverbal communications. In the work by Kerrigan et al., the authors measured the importance of blend shapes for animating facial expressions. In the 2 papers of Araújo et al., authors studied the influence of gender in different eras on the perception of charisma and comfort in CG characters. So we recreated the experiments of Queiroz et al. Minus the experiment that was in person, that is not online. We used the same questions and tried to recreate the micro and macro expressions animations using Unity 3D. We used a different character, used a female and cartoon to convey more comfort and charisma according to Araújo et al. And no hair to avoid bias. 6 emotions according to Ekman. The character had several blend shapes to replicate the expressions, and the questionnaire was done on Google Forms and transmitted on social media. So in the image above, the expressions made by our character, and in the image below, expressions made the character by Queiroz et al. The form was divided into 5 parts. The first one were demographic questions about gender, age, and other questions. The control questions, we presented the 6 macro expressions in image, showed videos of those expressions in a different order, and asked people what the macro expression was. The answers are all the 6 emotions. Experiment part 1, 6 micro expressions with videos followed by 1 question for each of them. The question was, what emotion was presented in the video? The answers are also the 6 emotions. Experiment part 2, it presents 20 videos with micro and macro expressions followed by 4 questions for each of them. What main emotion did the character show? Do you think the character is feeling any other emotions? What emotion? What is your comfort level in relation to the character featured in the video? What level of charisma does the character convey in the video? The last 2 questions we used Likert scales, higher Likert scales to the answers. So here is an example of one of the video presented in the control questions, macro expressions containing a happy expression in this case. Here, an example of one of the videos presented in the experiment part 1, the character doing a micro expression, in this case also containing a happy micro expression. The time was based on work by Queiroz et al. So the character do neutral expressions followed by a micro expression. And here an example of one of the videos presented in the experiment part 2, the character doing a micro and macro expressions containing a sad micro expression in this case, followed by a happy macro expression. The time was also based on work by Queiroz et al. So the character doing a neutral expressions followed by a micro expression, followed by a macro expression, and followed by a neutral expression again. The questionnaire was answered by 81 volunteers. We performed statistical analysis paired and independent tests. Regarding control question, participants had more than 80% correct answers. Regarding hypothesis 1, no significant result when comparing results in micro expressions. Both in experiment part 1 and part 2, the work of Queiroz had more correct answer than our experiment. Two aspects may have influenced this result. The first one is the technology has advanced a lot over time. So with more realistic animations in relation to the face, micro expressions may have become more imperceptible. And the second is the type of realism of the character. While we used a cartoon character, Queiroz and his colleagues use a realistic character. Overall, we can say that if designers, developers, animators, and the industry in general want to present macro expression, it doesn't matter if the character is cartoon or realistic, or if the technology is current or 7 years old. Then people will correctly perceive the emotion. The same is not true for micro expressions. Regarding hypothesis 2, in general, positive emotions were perceived more than negative ones. Participants perceived more macro expressions in videos that had positive micro and macro expressions than in videos with negative micro and macro expression. In this case, even if the animations are followed by negative micro expressions, designers and animators can create positive macro expressions that people will perceive, especially if the macro expressions are followed by positive micro expressions. And participants with CG familiarity perceived more negative macro expressions in videos that had macro and micro negative expressions than participants without CG familiarity. In addition, video game industries, which often have consumers familiar with CG movies, games, and others, can use negative macro expressions in their characters, as our results indicate that audience can perceive these expressions. Hypothesis 3, as foreseen the work by Araújo et al., our cartoon character was considered charismatic and did not generate discomfort for people. And about videos that started with positive macro expressions, people felt more comfortable and perceived more charisma. The results about charisma are in line with Ridge's work, in which the author describes charismatic individuals as lively and full of emotion. Therefore, in an industry that wants to convey charisma, unrealistic characters can focus on macro expressions, especially positive ones. So in the comparison between ours and Queiroz' work, the two characters evaluated presented similar results for the perception of micro expression. However, very different values for the micro expressions. In the comparison between positive and negative expressions, the results show that positive expressions obtain more correct answer than negative expressions, according to Cole et al., that the people can perceive more positive emotions than negative emotions in both evaluations, considering macro expressions and micro expressions. Regarding charisma and comfort, the results showed high values, showing that female cartoon characters correspond to what was shown in the literature, that people can perceive more charisma in cartoon characters and female characters, and people felt more comfortable with cartoon characters. In positive future work, we want to mitigate some limitations of the present work. For example, evaluating all the characters, testing all the combinations of micro and macro expression, and more. So these are our references used in this presentation, and thank you for your attention.
Thank you, Victor. That's a very interesting work here. While we don't get any questions, I'm going to ask you one here. Did you consider the context? I see that you're evaluating a very specific video, only the face of the character, no hair, no
Yes.
hair, no other background elements.
In this case, we do this because we need to avoid uncanny valley.
Yeah, yeah. But how do you think the perception of the humans would be affected by that? Like if we had this micro and macro expressions in a game, which you have a scene, several characters, they are communicating, how that would be affecting the perception? Do you think it would be reducing the perception or not?
It's a difficult question.
A more general one, probably this can be an interesting future work, but what do you think?
Yes, because we need to more test with realistic characters, for example, without cartoon characters,
Yeah.
And we need to compare the perception of cartoon characters and to compare the perception of realistic characters.
Yeah. It actually can be something interesting to test. Maybe you can test these both types of characters and create a small game, some small cutscene of a game, and see how that would be affecting the perception. Maybe just by having the hair on the character would be already affecting something. Or if you have a dialogue between characters and you want to see players can notice those small changes or not.
Yes, we need to test this character specifically with with hairs,
Yeah,
with different hairs.
Even Soraya is indicating here in the comments. Maybe we can test different contexts. Like you can have different scenes, different backgrounds.
Yes.
Maybe you have a different context, even in terms of narrative. Depending on the narrative, that might affect also the perception of the characters. Even the background of the character, like the history of the character, could also be affecting the perception because people know, even players know, the history of the character, what is the background of that character, and even that could be affecting the perception.
Yes, testing light, testing shadow.
Yeah, there are a lot of parameters here that could be tested here.
Yes.
Okay, let's see. I think we have one question here from Natalia. So, do you plan to evaluate male characters in future work?
Yes, we pretend to use male characters, and we pretend to use male and female characters, and we pretend separate the population. The demographic questions, demographic groups, women and men.
Yeah, maybe there are differences between the perception of different groups.
Yes.
Can be evaluated as well. Did you notice any difference on your current results or no?
No.
No? Okay. Okay, let's see if we have more questions. I don't think so. I'm going to ask the same question from the previous author. Like, what is your priority now? What is your next future work to continue this research?
I guess it use a realistic character.
Mm-hmm.
And realistic character with different skin colors too,
Yeah, now it's time to test the different parameters. Let's see
how
the parameters affect the perception.
Yes.
Yeah, that's good. Okay, all right. I think we don't have more questions, so we can finish the session. I just want to remember everybody that we have the final session, the ending session, the end ceremony, and also the award section after this section here. I think we start at 8. I don't know the time because I'm in another time zone. So yeah, check the program and see exactly. But after this session ends, we're gonna have the other. Okay. Thank you everybody for watching this session.